All right, here I'm going to work the two problems at the bottom of that Solving Genetics Problems worksheet, okay, where I wrote in orange as I added some things to the side of it, and it walks you through steps 1 through 7, okay. So the first problem at the bottom of the page, it says, in sheep, white is due to a dominant allele and black is due to a recessive allele. My suggestion is that as you walk through genetics problems, you break them down into segments, like I just did by stopping at the end of that sentence, okay. So, and yes, W is not always a great letter either, okay, but that's what's in the problem. So white is going to be due to a dominant allele, and black is going to be due, sorry, the bell is ringing, black is going to be due to a recessive allele, right? And it says a white ewe is mated to a white ram, right? So from just that information, the white ewe, which is the female sheep, this is all we know, is mated to a white ram. And that's all we know about those two parents. Okay, the ram's the male. They are going to produce a black lamb, right? And so as a result of that, the only way to produce a black, sorry, I'm getting tongue-tied, to produce a black lamb is for them both to have what allele? And pause and think, okay? So they're both going to have to be heterozygous. Right, and so that's your cross. Then you would show your alleles separating during meiosis, okay, during anaphase 1, the homologous pairs splitting apart, right, and so then you would take this and complete your Punnett square, okay. They both have the same genotype, and so, but the male alleles go on the top. So I typically fill these in this order. Some people's brains might work differently on that. Okay, and so then you would write out what are all the genotypes that are present in the phenotypes. Okay, as you see in number 6, I'm going to kind of simplify this, and I'm going to say that this equals white, and so does this. Heterozygous genotype. This one equals black. Okay, so then I'm going to give my genotypic ratio. Oops, sorry, didn't realize I wasn't on the screen. Had to look up for a second. Genotypic ratio equals 1 to 2 to 1. That's a lowercase w, with the correct genotypes combined with those numbers. Okay, then the phenotypic ratio is going to be 3 white to 1 black. Okay, so then let me do the other problem. Okay, ignore that my paper is torn at the top. All right, so we have in a man, normal pigmentation is due to a dominant allele, right? Okay, and then an albinism is due to a recessive allele. All right, so that's where somebody lacks pigment in their skin. Says a normal man marries an albino woman. Okay, so what we know, the man is normal. Okay, then we know the woman is albino. So there's your cross and all we know from that statement. Okay, the next sentence says their first child is an albino. Right, so that means that the man's second allele is going to have to be recessive. So then when we plug that into a Punnett square, and again, when we know male versus female, male alleles go along the top and female on the side, right? And so then it says, what are the genotypes of these three, oh, sorry, their first child's an albino, what are the genotypes of these 3 people? Okay, so you would list those technically. Let me work my Punnett square first, though, since that's what I was already doing. Okay, so heterozygous genotypes here and here, homozygous recessive there, all right? And so this is going to be the man, the woman, and then I'm just going to write child here. Okay, that's what my Punnett square looks like, and then it says if there are more children, what is the probable phenotypic ratio? Well, I'm going to give you the genotypic ratio as well. Whoops. Okay, so this is going to be a 2 to 2 genotypic ratio, 2 heterozygous individuals to 2 homozygous recessive individuals. That can be reduced to 1 to 1. Okay, phenotypically, we're going to get the same thing here. Okay, the physical expression. We're going to get 2 normal to 2 albino. Okay, and that can also be reduced to 1 to 1. All right, so anytime you are given a 1 to 1 phenotypic ratio, let's say you were given that and had to work backwards, then you would, this is what that Punnett square is going to look like. Okay, kind of more to come on that eventually. If you have any questions, let me know.